So here we have a function of two variable f, which is given by the inverse tangent of y over x. We need to find out the second partial of f with respect to x plus second partial of f with respect to y. So let's begin. So here we are given that our function f is equals to the inverse tangent of y over x. Now we'll take the partial on both sides with respect to x, which will be equals to taking the partial with respect to x of inverse tangent of y over x. So this will be equals to, so we'll use the derivative of an inverse tangent function. We have ddx of tangent inverse of x, so that's equals to 1 over 1 plus x squared. The same rule is going to get applied here, so this will be equals to 1 divided by 1 plus y over x whole squared multiplied to partial with respect to x of y over x. Right. So this is going to give us x squared divided by x squared plus y squared. Now since we're taking the partial of y over x with respect to x, if y will be treated as a constant, so we can now pull it out of the derivative, and we all have to find out partial with respect to x of x raised to the power of negative 1. Right. So let's find it out. So we have partial of f with respect to x. So this will be equals to x squared times y divided by x squared plus y squared multiplied to partial derivative of x raised to the power of negative 1. So that will be negative 1 divided by x squared, which will be equals to, so here x squared and x squared will get cancelled. We have negative y divided by x squared plus y squared. So this is the value of partial of f with respect to x. Let's label this as number 1. So our next talks will be to find out the second partial derivative of f with respect to 1. So let's begin. So we'll take the partial derivative on both sides with respect to x. So we have partial with respect to x of partial derivative of f with respect to x equals to partial derivative with respect to x of negative y divided by x squared plus y squared. So this will be equals to, so here y will be treated as a constant, so we have negative y multiplied to partial with respect to x of x squared plus y squared. We're taking the denominator to the numerator, raised to the power of negative 1. So this will be equals to negative y multiplied to negative 1 times x squared plus y squared raised to the power of negative 2. So here we have used the power rule, but we'll also have to multiply it to partial with respect to x of x squared plus y squared. Yeah, this is the chain rule. So this gives us y multiplied to x squared plus y squared raised to the power of negative 2 times partial with respect to x of x squared plus partial with respect to x of y squared. So that means we now have second partial derivative of f with respect to x. Now this will be equals to y divided by x squared plus y squared multiplied to the partial derivative of x squared with respect to x will be 2x plus partial derivative of y squared with respect to x will be 0 because y is a constant here. So this finally gives us 2 times xy divided by x squared plus y squared. So this is the second partial derivative of f with respect to x. So this is number 2. Now we will find out partial derivative of f with respect to y and its second partial derivative as well. So let's find it out. Again, we'll begin by using f equals to the inverse tangent of y over x. So let's take the partial derivative of f with respect to y. So this will be equals to partial with respect to y of inverse tangent of y over x, which will be equals to 1 over 1 plus y divided by x whole squared multiplied to partial with respect to y of y over x. So this will be equals to x squared divided by x squared plus y squared multiplied to, so since we're taking the partial with respect to y, so x will be treated as a constant, so we can pull it out 1 over x from the derivative. So this will be multiplied to partial derivative of y with respect to y, which gives us partial of f with respect to y equals to the 1x from the denominator, 1 from the numerator goes away. So we have x divided by x squared plus y squared. So here partial of y with respect to y, so that value is equals to 1. Let's label this as number 3. So we'll now use number 3, which is partial of f with respect to y equals to x divided by x squared plus y squared, and then we will take the partial derivative on both sides with respect to y. We have partial with respect to y on the right hand side as well. So let's find it out. So this will give us the second partial of f with respect to y. So here we have x as the constant, so we can pull it out of the derivative. So we have partial with respect to y of x squared plus y squared raised to the power of negative 1, which will give us x multiplied to negative 1 times x squared plus y squared raised to the power of negative 2 times partial with respect to y of x squared plus y squared. So this will be equals to, so we have negative x divided by x squared plus y squared whole squared times, now partial of x squared with respect to y will be 0 and partial of y squared with respect to y will be 2y. So we have also obtained second order partial, the second partial derivative of f with respect to y. So let's label this as number 4. So we had obtained the second partial derivative of f with respect to x and second partial derivative of f with respect to y. We see that both of them are exactly the same expression except for a negative term, so that means they're additive inverses of each other. And finally we can say that when we add the two terms, that will be the second partial of f with respect to x added to second partial of f with respect to y. So this is simply equals to 2xy or divided by x squared plus y squared whole raised to the power of 2 minus 2xy divided by x squared plus y squared whole raised to the power of 2. So this will be equals to 0. So this is the final value.